G'day. Welcome to the labs at Bushy Park Estates, Tasmania, Australia. I'm Owen Johnston, Head of Sales and Marketing for HPA. Joining me is Nathan Kalman, Brewery Manager at J. Bogan Son, the local Lion brewery here in Tasmania. We're going to dive into the science behind quality management with our Quality Manager, Peter Hamilton, and our Lab Coordinator, George Webster.
We take pride in our hops and the beers you make with them. That's why we have a no-nonsense quality management system. It's ISO 9001 and HACCP certified, so brewers can be always assured that they're going to get high-quality Australian hops.
Quality starts on the farm. We have a team of around 20 people spread across the business who are tasked with maximising the quality of our hops from the vine through to the final package. And this lab is the centre of it all.
We have labs on each of our farms and they have a pretty high throughput over harvest, so it's important that our methods are easily repeated and very robust. In the lead up to harvest, the quality team moved through every single garden 3 or 4 times, taking a representative sample of hop cones from the vines to determine when each variety is ready to be harvested. This is done by regular analysis of gland fill, cone weight, dry matter, alpha acids, beta acids and oils.
G'day George.
G'day AJ, g'day Nathan.
G'day. So we're heading into harvest. What are the key indicators that tell you that a variety is ready to start picking?
One of the key indicators is the maximum accumulation of alpha acid with the maximum accumulation of oils. So there's a process of metabolite accumulation that occurs through hop cone maturation, and that's through from the flavonoids to the beta and alpha acids to the sesquiterpenes and monoterpenes, and then finally the thiols.
We also need to consider dry matter and cone weight to achieve an economical yield. When a variety is ready to harvest, it goes through our standardised production process to ensure the hops meet our specifications every step of the way.
Nathan, the first stage in the process is picking. We conduct extraneous matter tests regularly throughout each shift. This involves separating the hops from the stem and leaf and weighing both. The results of these checks are generally under 1%. If it starts to creep up, we know we need to adjust the speed of the picker, the speed of the fan, or the angle of the dribble belts to get it back down again.
So how deep do you need to fill the kiln here before you start the process?
We fill the beds up to 600 mils. We fire the burners up and they come up to 65 degrees, and then we dry the hops between 8 and 12% moisture. This can take anywhere between 8 to 12 hours, so we check the moisture levels after 8 hours, then more and more frequently from that point on until they are in spec.
So I've seen the operators waiting around here through the hops. How do they measure the moisture level during kilning?
They use a moisture meter, and they walk in a diamond pattern across the floor, and so they're measuring from the centre out to the extremities of the kiln floor. As soon as the probe returns a reading within the target range, the burners are turned off and the floor is cooled. And then the kilned hops are dropped into the conditioning floor where they rest for at least 12 hours to allow the heat and the moisture levels to distribute evenly.
So what happens to the hops next after that 12-hour period?
We press them into bales that have strict temperature and moisture specifications. Moisture must be between 8 and 12%, and temperature must completely stabilise before we transfer them to our warehouses. Any bales that don't meet these specifications remain in the processing facilities for corrective action. We allocate a different lot number to every pallet, which is equivalent to 6 by 110 kilogram bales, and conduct auger sampling on every lot number to confirm it is in spec.
So this year we have a new lab set up next to the bale press so that we can get results for alpha acid and oil contents in a much quicker fashion.
That's got to be really good for quality, doesn't it?
Yeah, so it means we're producing hop storage index values for every bale that comes through, which will give us better quality outcomes in the blends.
What sort of lab methods do you use to analyse your auger samples?
So we use a few different pieces of equipment. In the past we've used lead conductance value to produce alpha acid content, but we've since phased that out for sustainability reasons. Now we use near-infrared spectroscopy, which is much safer and more efficient. We've been running NIR in parallel with the ultraviolet spectrophotometer, distillation and moisture analysis to continuously improve the accuracy of our model. The UV spectroanalysis gives us our alpha and beta acid values as well as our hop storage index, and the distillation apparatus gives us our oil content. But this is a relatively slow manual process that takes around 3 hours per auger sample, whereas NIR is faster, indirect, and only takes around 5 minutes per auger sample since no analyte extraction is required. So with the NIR, we've been able to increase the number of oil contents we can produce from 6 samples a day to 60. And we now have the capacity to produce oil content and HSI values for every bale during harvest on top of alpha content. NIR is also employed for all our pre-harvest analysis.
Nathan, once the bales are in spec, we use digital thermometers to measure the temperature of the pellets and also throughout the process.
So is there a point in this process where it's really critical to maintain temperature?
That'd be where the powder passes through the die, at which point it should be a maximum of 55 degrees Celsius to make sure that the pellets hold their shape in the final package. We also conduct hourly density checks for the same reason. Then once they've been cooled, the pellets are packaged into oxygen barrier laminated foil pouches from which the oxygen is evacuated before being backflushed with carbon dioxide and sealed. The seal is currently checked by a visual inspection and a Hague leak detector to make sure that there are no leaks that could lead to increased oxygen levels in the foil. And we use a gas analyzer to test the carbon dioxide and the oxygen levels within the foil.
So you've got a really strong focus on maximising the benefit of your hops in the finished product. There's often a long time between when your hops are packaged here and we brew beer with them. What do you do in that period to make sure that, the quality of the hops is maintained?
Our packaged hops are transported to warehouses across Australia, where they're stored between 0 and 5 degrees Celsius until they are called up by the brewers. We have long-term relationships with our warehouse contractors who all have climate monitoring systems in place. We also include them in our annual internal audit to ensure the conditions continue to support high quality in the final package.
I think you'll agree, the way brewers use hops has changed significantly over the years. It's more important now than ever to understand the information we present from our quality checks. Every box has a lot code that links back to a certificate of analysis. It's the COA that has a standardised presentation of information relating to alpha, beta, oils, moistures. It's a way for brewers to measure slight differences year on year or lot by lot so they can adjust their recipes accordingly.
The lot number also allows for complete traceability from where the hops were grown to how they were sprayed to when they were harvested and how they were dried. This level of detail ensures we adhere to the chemical guidelines of countries around the world.
Every aspect of our quality management system is designed to ensure only the highest quality hops get into the hands of brewers. We're continuously investing in quality improvements so that you can get the absolute maximum flavour out of our hops and continue brewing and drinking consistently delicious beers.